Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem Count the Elements. So, now let us see what this problem has to offer. In this problem, you are given three arrays. The array A, such as 4, 1, 2. The array B, which tells me 1, 7, and 3. And one more array, that is query, and these two would be of the same size, like they are akin to each other, brothers, and this would be different, that is, let's say 0 and 1. Okay, so this query array, as the name suggests, here you need to report out the queries that are asked. So now this array would tell me the index of A, that is 4. Okay, now it is asking me how many elements are less than equal to 4. So we have 1 and 3. So that is why the answer to this is 2. Now, next, in the next phase, it is asking me the index 1. So now I need to report how many values are less than equal to 1. That is this value. That is why the answer is 211. Didn't understand it? No issues. Let's take the next example, which is comparatively better. Okay. So we have 1, 1, 5, 5. And then we have the array B, which is 0, 1, 2, 3. And the array Q is 0, 1, 2, 3. And here we have 5 again. So now, the very first one, 0th index. So we would go to A, ask what is your 0th index? 1. So how many values are less than equal to 1? That is, there are 2 values. So I would write here 2. Okay. Then it is telling me 1, the index 1. I go to index 1, the value is again 1. So the number of elements are again 2. Then it is telling me go to index 2. I went to index 2, it is telling me 5. So how many values are less than equal to 5? There are 4 values that are less than equal to 5. That is why the answer is 4. Then it is asking me go to index 3 and tell me how many values are less than index 3. That is 5. Again, how many values? That is 4. That is why the answer to this is this. So now what you really need to do is, at each step, you would be given a value x, and you need to report the count of values less than count of values which is less than equal to the value x. How can I do it, Siddharth? And I don't need to do this rapidly. The very first way is using the brute force approach. I would simply cycle over all the elements, and all the values that are less than equal to those values would give me the answer. And that is big O of n for each query. For replying one query, I need to have big O of n operation. So for replying q queries, the time complexity would be n multiplied by q. Can I do better than this? So better approach would be to, like, let's say I have something like, let's say this is 2, 4, that's 0, 4, 6, 7, 9. Okay. So what I can do is, I can build out a prefix sum kind of thing for them. Okay. Where I would build out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now see how the intuition for prefix sum would be there. So I need to reply rapidly. How many values less than that. So what is prefix sum? Prefix sum is nothing but sum till this point, sum till this point, sum till I is prefix sum. So prefix sum is what? Sum till I. So can't I have something like count till I? Count till I. If I make all the values as 1. Let's see. Let's say we have here 2, 4, 1, 3. So if I have all the values as 1, then the prefix sum would look something like 1, 2, 3, 4. This is just telling me count till this value, count till this value. So same thing I would do. Initially, every value is 0. I saw a value 0. Now I would start processing. I saw a value 0. I made it 1. I saw a value 2. Made it 1. I saw a value 4. Made it 1. I saw a value 6. Made it 1. I saw a value 7. Made it 1. I saw a value 9. Made it 1. Now, let's build out the prefix sum. So it would, if you see cunningly, it would give me the number of values that are present like this. So see, this is 1. 1 plus 0 is equals to 1. 1 plus 1, 2. 2 plus 0 is equals to 2. 2 plus 1 is equals to 3. 3 plus 0 is equals to 3. 3 plus 1 is equals to 4. 4 plus 1 is equals to 5. 5 plus 0 is equals to 5. 5 plus 1 is equals to 6. Now, the idea is that this was the array. Now see, if you ask me, how many values are less than 6? So I would simply go to 6 and ask him, how many values are there which are less than equal to 6? He would tell me 4 values. See, and they are actually 4 values. If you ask me how many values are less than equal to just 2, I would go and ask, yeah, just 2. So only where the elements are present, they are contributing to this. So if I simply, like this is a sorted array kind of thing, and 1 is not present. So number of values that are less than 2 and are present would come and contribute to this value. This value is what? Number of elements that are less than 6 and are present. They are contributing to this. How they are contributing? All the elements which are present, they are contributing 1, 1 to each one. And that is why this value is 4. All the elements which are not present are contributing 0. So this is how, by using the property of prefix sum, we are having the count of the elements which are less than equal to the given value. So we would use this. And what is the size of the array that is needed? If you observe, the maximum value was 9. So size of the array needed is maximum value plus 1. The size of this array is 10. So we would find out the maximum value, declare an array of size plus 1, and we would start hashing it. All the other initial values would be 0. And at the end, we would just build out the prefix sum. Whatever is asked, we would give it back. Okay, let's do this, and then we would talk about what is the improvement here. By the way, I can just tell you here itself at this point only. See, the improvement here is we are processing each element. We are processing each element and writing it down in this array. After that, we are processing this array exactly once and then writing down these elements. Now, this thing would take big O of n. Okay. Now, after that, to reply a query, I just need to go at this index and report the value. So I can reply one query in a constant operation. So Q query would be replied in big O of Q operation. So time complexity would be, this is the max value. Time complexity would be max of A of I, whatever the value was, plus the value of big O of k plus the value of k. And the space complexity would be the maximum size of the element that is present in the array. Now let us start implementing this. So I would make the size of the query array as m and this as q only. Okay. Now initially we don't have any maximum, so m maximum value is -1. Now let us find out the maximum value. So for auto E of which array we need to say, of B, of the eighth array, of the array A, because we need to find elements less than the maximum value of. So now mx is equals to max of whatever was already stored or the current element. So this is just finding out the maximum element in an array. Then we also need, let's say here it is asked only 5, but here let's say we need to hash the value 10. So that is why we would take off this precaution too and find out this. But we can say if a maximum value more than, we don't really need to take this precaution. Why? Because let's say we are trying to hash 10, but it would never be asked because the maximum value asked would be 5. So we can just ignore the values by introducing an if statement that if the value that we want to hash is more than what would be asked. Like अगर मुझे पता है कोई चैप्टर सिलेबस में नहीं आएगा तो ज़्यादा पढ़ के फायदा नहीं, हम बस एक चीज़ पता कर सकते हैं, जब हम पढ़ने जाएंगे तो बस देख सकते हैं वो सिलेबस में है या नहीं. This is the example. So I would just keep this scenario to handle by itself, and here I would have a frequency, like I would simply have vector int of the frequency array with size mx plus 1 and all the initial values would be 0. Okay. Now I would start hashing values of the elements that is present in B. Now I would first check if E is less than equal to what would be the maximum value that would be asked. अगर मैं उसके लिए आंसर तैयार कर रहा हूँ 10 के लिए और मैक्सिमम मुझसे 5 तक ही पूछा जा सकता है, there is no point in preparing a hash value for that. So that is why we would just write if E is less than equal, अगर वो सिलेबस में पूछा जाएगा तभी मैं उसे hash करूंगा. So I would simply say that frequency of E, and I would simply make it as 1. Okay, or plus plus, sorry, or plus plus, because at one position more than one value can exist. Okay, so now I would start with the second element because the first element would remain as it is, and I would just, here I made one different array to show you this, but here I would do it in the same array because we don't need this array ever again. So I would use the same array. So for int I is equals to 1, I is less than equal to mx and I plus plus, and we would say f of I is equals to f of I plus equals to f of I minus 1. Okay. Now we need to return the answer in the form of vector. So we would initialize a vector of answer. Now we would start processing all the queries, auto E of query. We would start processing all the queries. Okay. And we just need to push out the value that is present in the prefix. So answer dot push back whatever is present in the frequency array, and then return the value of the answer. Now let us just compile and see how many errors are we making. Seems like we made some errors, so I would just check what are the errors. So mx is equal to, we would have the maximum value, so we would make a vector of mx plus 1. So A would be, let me just recheck. A would be the query that is asked. Yes. For auto B, we need to report the elements that are less than in B. Yes. So if the element that is there is less than equal to the value mx, then only move forward and hash it. Okay, so I returned all the value of q. So I need to, this q would give me the index what needs to be accessed from me. So for int I is equals to 0, I is less than m and I plus plus, and this q would give me the value. So value would be, q would give me the index of a. So a of q of I, this would give me the value, and answer dot push back, this would return me the index. So f of a of value, this should work as expected, and this should be the issue. 2211, and here it is. So now let us see what this array is returning. The elements less than 0 equal to 0 is equal to 1, the elements less than 1, 2, 3. So here it should be simply val. I did another nesting. Okay, this is me being me, and I would just uncomment this out to compile and run. Seems good. So this is how, yep, the values are matching. Now let us try to submit this and see if we can get an AC or not. And yes, we got an AC. So again, a lot of hard work was taken for this problem. I went up from the very bottom to the end of this problem. There is one more solution that exists around this without using any auxiliary space. That is by sorting the array itself and using something known as binary search lower bound and upper bound. So you can explore that if the interviewer is telling you, can you do this without using any auxiliary space? But that won't really be an efficient solution because the time complexity for replying each query would be log n, not constant. But you can save on the auxiliary space that you are using. But explaining that solution won't make it as an easy solution. So I would highly recommend you to go and explore if you don't really know it. That's it for today. Thank you and have a nice day. Goodbye, everyone.